All right, hello grade 9s. Welcome to the second lesson in this unit. You might see that it says 6.3 at the top. That's just because I skipped 6.2 just because we don't have a lot of time left. We got a lot of stuff to get through, and it was just kind of more of the same transversal stuff. Remember that line that cuts across two parallel lines with all the angles. So what I would like you to do is to pause and try to answer this question to yourself. Maybe make a list of all the different types of triangles that you remember from elementary school. Okay, hopefully you paused and did that. Here we go. We've got equilateral triangles. I'm sure you remember those. Those triangles have all sides the same. So when I put a little tick on each side, this tells us that they're the same. And we know that if all three sides are the same, then all three angles have to be the same too. And just so you know, I didn't use a ruler here. I didn't measure the angles, but this triangle would be marked perfect for an equilateral because I've said the sides are the same and the angles are. So don't worry about rulers and that sort of thing anymore. All right, so in an isosceles triangle, we've got two sides that are the same and two angles that are the same. And a scalene triangle is just really any triangle. I'm not going to draw that because it looks like a right triangle. Let's draw this guy here. Okay, so it's a triangle where all three sides are different and all three angles would be different as well. All right, an acute triangle, well, I actually just drew an acute triangle. That's where all three angles are less than 90. In an obtuse triangle, we have one big angle that's greater than 90. And in a right triangle, of course, we have a right angle. And the side lengths don't matter for these, it's just about the angles. All right, moving right along, the interior angle theorem is something you probably already know from elementary school. So I'm going to start it off here. The angles in a triangle always add up to, and I would like you to fill in this blank. All right, hopefully you took a second to think about that. And it is, the angles in a triangle always add up to 180 degrees. And this fact, this theorem will allow us to solve all sorts of different problems with triangles where we're missing one angle or we're missing two angles, and we have to figure out the missing angles. So let's jump right into it, fill in the blanks here. Angles inside any triangles add to 180 degrees, and a corner of any shape is called a vertex. Again, so far this should all be review from elementary school, and if it's not, you can pause and rewind, watch it again, and just take it in. All right, example 1, determine the measure of angle A. Now, I suspect you could all probably do this, so I would encourage you to pause, find your answer, and then unpause to see if you did it correctly. And just as a reminder, last week when we had our first lesson, when I say justify, you need to tell me the theorem. And today that theorem is IAT. Last week it was Z pattern, F pattern, co-interior angles, X pattern, all that sort of stuff. So try this out and then come on back. All right, so this is a 3-mark question. So angle A equals, the first thing I do is I show my calculation. I start with 180 and I subtract the other two angles. And angle A is going to be 180 minus 36 minus 46, and I get 98 degrees, which was the name of a sweet boy band back in the 90s or early 2000s. Check it out. And then I'm going to say by IAT. So remember, your 3 marks here are going to come 1 mark for showing you the work, 1 mark for the right answer, and 1 mark for the theorem. So if all you wrote was 98 degrees, you'd get 1 out of 3, which is 33%. So these are easy marks, but they do take a little bit of time. And you might think, what's the point of all this? Well, the point is that as you move forward in math, the problems are going to get more complex, and it will get more and more important to stay organized, to show your thinking, to show your work. And if you get in the habit now, it'll just be natural at that point. All right, example 2. Determine the measures of D and F and justify. Again, I would love for you to pause and to try this one. It's a little bit tricky. But I encourage you to take the hint, what type of triangle is it? All right, I am hoping that you paused it and tried it. So first of all, angle D, we're going to take 180 And we're going to subtract the 124, but wait a minute, we don't know angle F. So I'm going to erase this angle D equals, because that's not actually going to work. So 180 minus 124 is 56 degrees. So what this means is that when we take out this angle, we've got 56 degrees left for both of these. Now, if you notice the ticks here, you'll know this is an isosceles, so you know that this and this are the same. So what we can say now is that angle D equals angle F, and that is equal to 56 degrees cut in half, which is 56 divided by 2, which is 28 degrees. And now for the justification. We're going to say here by IAT, and that's because we know that the angles add to 180, and we're going to say and by isosceles. And that's because when we divided by 2, that only worked because this is an isosceles triangle. That's it, folks. I'm not really going to show you anything else here today. It's a nice quick 6-minute lesson. I think that's a new record. This is a nice quick day. In class we would have done some fun investigations and some games, but unfortunately we're not really in that position right now. So I'm going to go through your homework with you just so that you know what you're doing. So show your work, give your reasoning, justify. So that's using IAT for each one. Nothing special here, just 3 regular triangles. And then here I'm saying, can a triangle be drawn with these 3 angles? Well, I guess my question is, what do the angles have to add up to? They have to add up to 180. If they don't, then it doesn't work. Okay? Can a triangle have 2 90-degree angles? I want you to think about that and answer that question. And then we got a couple little application questions. So the angle shown is 40, so that's this guy. It has all 4 sides equal, so that means that this, this, and this are all equal. So I'll let you take it from there to try and find this angle, and again I'll post the solutions. And then part B, what if the angle increases to 42? What happens to the angle at the top? So how much does it go up or down by, and explain how you know. And try and do it without redoing the whole question. And I think that's it. Okay, so that should be pretty easy. If you have questions though, as always, send me an email, and I'm happy to make a video of a question you need help with, or if you want to set up a Google Hangout or a Google Meet, I'm happy to do that as well and give you some live help. And if you're still doing this stuff, thank you. I think you'll be happy for it in grade 10 when you know a lot of stuff that some of your classmates might not, because they've sort of given up at this point. And if you have some friends in the class that aren't doing anything, encourage them to do it. It's easy, you got nothing to lose, right? So take your time with it, and all your mark can do at this point is go up. So I think it's worth the time, and summer's coming soon. We got another less than 2 weeks of this, and it's done. All right, folks, so again, get in touch if you need any help, and thanks very much.